darkness, silence. The vastness of space stretches infinitely, a canvas of endless possibilities, an endless expanse of cold, dark nothingness, a void so immense it's almost incomprehensible. Then a spark. A giant cloud of gas and dust disturbed by a cosmic event began to collapse. This disturbance could be a nearby supernova or the gravitational pull of a passing star. Gravity, a powerful force, pulled everything inwards. The particles within the cloud started to clump together, drawn by their mutual gravitational attraction. The cloud spun faster and faster. As it contracted, its rotation speed increased, much like a figure skater pulling in their arms to spin faster. It became a whirling vortex of cosmic dust. The center of this vortex grew denser and hotter, a chaotic dance of particles. At the center of this maelstrom, a star was being born, our very own sun. The core temperature soared, reaching millions of degrees. The intense pressure and heat at the sun's core ignited a nuclear furnace. Hydrogen atoms fused to form helium, releasing vast amounts of energy. Light and heat blazed outwards, pushing against the swirling cloud. This radiation pressure balanced the gravitational collapse, stabilizing the young star. This is how our solar system began. A chaotic mix of energy and matter constantly moving and colliding. Over millions of years, these collisions formed planets, moons, and other celestial bodies, creating the dynamic system we call home today. In the outer reaches of this swirling cloud, far from the sun's fiery heart, tiny dust grains danced. These grains, seemingly insignificant, were the building blocks of something much greater. They floated, aimlessly, carried by the cosmic winds, waiting for the right moment to begin their journey. These weren't ordinary dust particles. They were remnants of ancient stars, rich with elements like iron, silicon, and oxygen. Each particle held within it the history of a star that had lived and died, contributing its essence to the vast expanse of space. These elements were crucial as they would eventually form the foundation of planets, moons, and even life itself. Drawn together by an invisible force, gravity, these particles collided and stuck. This process was slow and delicate, with each collision adding to the growing mass. Over time, these tiny grains began to form larger and larger clumps, setting the stage for the creation of celestial bodies. Over millions of years, these tiny specks grew larger. The process was relentless, with each new collision adding to the mass. These clumps, now significantly larger, began to attract even more particles, accelerating their growth. The once tiny grains were now on their way to becoming something much more substantial. As these clumps grew, their gravity strengthened, pulling in more and more dust and gas. This gravitational pull was a crucial factor, as it allowed the clumps to gather even more material from their surroundings. The growing masses began to take on a more defined shape, hinting at the planets they would eventually become. They spun faster, becoming molten balls of rock and metal. The intense heat generated by the collisions caused the material to melt, forming a molten core. This spinning motion was essential, as it helped to shape the young planets and distribute their mass evenly. This is how our planet Earth was formed, a fiery ball of molten rock, still under constant bombardment from the leftover debris of the solar system's formation. The early Earth was a hostile place, with frequent impacts from asteroids and comets. These collisions played a significant role in shaping the planet's surface and contributing to its eventual habitability. Over time, the Earth's surface cooled, forming a solid crust, and the stage was set for the emergence of life. Imagine a time when the young Earth was a molten hell, its surface a fiery landscape of flowing lava and erupting volcanoes. The air was thick with toxic gases, and the ground was a seething mass of molten rock. During this chaotic era, the Earth was constantly bombarded by asteroids and comets, each impact adding to the turmoil. These celestial bodies, some as small as pebbles and others as large as mountains, crashed into the Earth with tremendous force, releasing energy equivalent to millions of nuclear bombs. This relentless assault is known as the Late Heavy Bombardment, a period of intense cosmic chaos that lasted for hundreds of millions of years. It was a time when the young solar system was still settling into its current configuration, with planets and moons jockeying for position. The solar system was a turbulent place, with countless asteroids and comets hurtling through space, colliding with planets and each other. This cosmic dance of destruction and creation played a crucial role in shaping the planets and moons we see today. During this tumultuous time, a Mars-sized object, often referred to as Theia, slammed into the Earth in a cataclysmic collision. The impact was so powerful that it melted a significant portion of the Earth's crust and mantle, sending debris hurtling into space. This debris, a mixture of molten rock and dust, formed a ring around our planet. The ring glowed with the heat of the impact, a fiery halo that slowly began to cool and coalesce. Over time, the debris was pulled together by its own gravity, gradually forming larger and larger clumps. These clumps collided and merged, growing into a single massive body. This body cooled and solidified, eventually becoming our constant companion in the vastness of space, the Moon. The Moon's surface, scarred by countless impacts, tells the story of its violent birth and the tumultuous early history of our solar system. The Moon's gravitational pull stabilized Earth's rotation, creating a more stable environment for life to eventually emerge. Its presence has influenced the tides, the length of our days, and even the tilt of our planet's axis, making it a crucial player in the story of life on Earth. The early Earth was a world of fire and molten rock. Volcanoes erupted across its surface, spewing lava and gases into the primitive atmosphere. The surface of the Earth was a giant magma ocean, with temperatures so high that no life as we know it could exist. As millions of years passed, the Earth began to cool. The molten rocks solidified, forming the first continents. Water vapor, released from the planet's interior by volcanic activity, began to condense in the cooler atmosphere.